Welcome, and let's solve this tricky exponential equation together. It's just so easy. And don't forget to tell us how it helps you in the comments. Let's do this together. So we're going to begin with our solution. Let's repeat what we have. 3 to the power of x plus 9 to the power of x plus 27 to the power of x is equal to 14. Now, when you look at this, you observe that this can have powers of 3. We know too well that 9 is 3 multiplied by 3, which is 3 squared. 27 is 3 multiplied 3 times, which is 3 cubed. So we can rewrite this to give us 3 to the power of x plus 3 squared to the power of x plus 3 cubed to the power of x is equal to 14. Now, at this point, just remember, for every a to the power of m raised to power n is a to the power of m multiplied by n, which is a to the power of n raised to power of m. Now, we are going to apply it here. We have 3 to the power of x plus 3 to the power, switch the power. Watch, these powers were switched. So we have 3 to the power of x raised to power 2, 3 to the power of x cubed is equal to 14. These two are the same. Now you observe that this is repeated. So quickly use a variable to replace it just to help you solve. So we now say let 3 to the power of x be equal to y. Plug this in the above. We have y plus, this will be y squared plus y cubed is equal to 14. What did you observe? This has led you to a cubic equation because the highest power of y is 3. Now, at this point, we are going to ask ourselves question, is there a number we can get from the factors of this 14 such that when we have that number, add it to the square of the number and the cube, it will be giving us 14. Remember, we're going to get it from the factors of 14, both the positive and negative. So we have positive and negative 1, positive and negative 2, positive and negative 7, and so on. Now let's try for y as 1. So we have 1 plus 1 squared plus 1 cubed. This is not equal to 14. You try negative 1. You have negative 1 plus negative 1 squared plus negative 1 cubed. This gives you negative 1. When you square negative, it gives you positive. And when you cube negative, it returns you to negative. So this is not also equal to 14. Now let's check for when y will be 2. We have 2 plus 2 squared plus 2 cubed. This gives us 2. Here is 4. And this is 8. So you see that when you add this, it gives you 14. So that factor that suits it is y being 2. And it's going to help us to solve. So to keep solving, we have y plus y squared plus y cubed. Replace this 14 with what we have here. So we have 2 plus 2 squared plus 2 cubed. And that is what gives us 14. So we are going to now have y. Remember, this is positive. Take it to the left. It is negative 2 plus y squared. Take this to the negative. Is negative 2 squared plus y cubed. This will be negative 3 cubed. And everything will be equal to 0. So what do? We keep solving. Now remember that these two are together. These two are together because of their powers. And these two are together. So we're going to have y minus 2 plus, now when you have this, it reminds you of your algebraic identity, which is whenever you have a squared minus b squared is a plus b into a minus b, difference of two squares. And this one reminds you of a cubed minus b cubed is a minus b into a squared plus ab plus b squared, your difference of two cubes. So if you apply these identities on the above, let's take it to this part. So let's clean this. So to do that, we now have from here, y minus 2 plus, for this, apply the first one. So we have y plus 2 into y minus 2. Then for the last one, we have y minus 3. We are using this into y squared plus AB means to multiply this. So we have y multiplied by 3 plus 3 squared. Everything is equal to 0. So this gives us y minus 2 plus y plus 2 into y minus 2 plus y minus 2. Please let's correct this. This is y minus 2 cubed. Sorry about that. So let's effect it here. We also have y minus 2. So that's what we have here. So this will still be y multiplied by 2, and this will be 2 squared. So we have 2 squared. So we now have y minus 2 into y squared. Multiply this, it gives you 2y. This will give us 4, and everything is equal to 0. You observe now that, remember, these two are together as well as these two. So you observe that y minus 2 is repeated in the three part. So we're going to factor it out to have y minus 2 factored. Let's open a big bracket. If this divides itself, it gives you 1 plus, when this divides these two, we are left with y plus 2. Then plus, when this divides this, we are left with y squared plus 2y plus 4, and everything is equal to 0. So simplify, we have y minus 2 into 1 plus, open up the bracket, y plus 2 plus y squared plus 2y plus 4 is equal to 0. So we have y minus 2 into, let's begin with the one with highest power. 2y add y gives us 3y. 4 add 2 add 1 gives us 7, and is equal to 0. Now for every AB to be equal to 0, either A is 0 or B is 0. So we are going to have y minus 2 is equal to 0. And in that case, to get y, add 2 to both sides. So if you do that, this takes off. So we have y will give us, add 2 here, it gives you 2. So the first value of y we got is 2. Now let's work for this to have. Solving for the second one, we have y squared plus 3y plus 7 equal to 0. This is your quadratic equation. Now we are going to check for the discriminants of this to help us to know if we're having a real or complex solution. If it's complex, we are going to reject, and if it's real, we accept. So to check for the discriminant, we know that our D is b squared minus 4ac. And if this is greater than or equal to 0, it means we are going to accept, that is real. And if our D, b squared minus 4ac, is less than 0, it is complex, and we are going to reject it. So let's test this in this statement. Remember, your A is the coefficient of y squared, which is 1. Your B is the 3, and your C is 7. Let's plug this here to have D is equal to, our B is 3, so we have 3 squared minus 4 multiplied by 1 multiplied by 7, and it gives us D. This will give us 9, and when you multiply this, it gives you negative 28. And you know that when you subtract this, it is a number that is less than 0. And in that case, it is complex, and we are going to reject. So we reject this solution. So we are going to have it that the acceptable value of y is equal to 2. So this is the acceptable value of y. But remember, we are to get x and not y. So we need to recall we made a statement. So we recall we said that 3 to the power of x is equal to y. So in that case, we are going to have 3 to the power of x. Our y accepted is 2. So what we need to do here is to take log of both sides, And for you to also have watched through this point, it shows what you'd be interested. Don't forget to like this video, share with your friends. It helps the algorithm to send to more people. If you are still new, hit the subscription button. We have a lot to give to you every day. Thank you, and let's keep doing this to have log of 3 to the power of x is equal to log of 2. Remember, for every log of a to the power of x, it is x log a. So if you apply this rule here, we have x log 3 is equal to log of 2. To get x, divide by log of 3 and do same here. So when you do that, this takes off. So we have x is, so let's take it to this part to have x is equal to log of 2 divided by log of 3. Remember also, for every log of a divided by log of b is log of a base b, your change of base rule. So if you apply it here, we now have from here, our x is giving us log of 2 base 3. So this gives us the value of x for this equation. Now we're going to plug this x value on the left side of this equation to see if it gives us back 14. And that is the most interesting part. I wouldn't want you to miss. Let's do this verification together to have. To verify, we have 3. Our x is this, so we have log of 2 base 3 plus 9 log of 2 base 3 plus 27 log of 2 base 3. Will this give us 14? Let's see to that. So we have 3 to the power of log of 2 base 3. Remember, we said 9 is 3 raised to power of 2 and is raised to power of log of 2 base 3 plus, this is the same as 3 cubed will be raised to power of log of 2 base 3. Keep simplifying. So we now have 3 to the power of log of 2 base 3 plus, remember we said these powers will multiply. So it gives you 3 to the power of 2 log 2 base 3 plus, multiply this, we have 3 to the power of 3 log 2 base 3. Now, remember what we stated, this coefficient is the power of the log. So we're going to have it as 3 log 2 base 3 plus, this will become the power. So we have 3 to the power of log of 2 to the power of 2 base 3 plus, also do same here, we have 3 to the power of log of 2 to the power of 3 base 3. Now at this point, just remember, for every a to the power of log of b base a, these two are the same. It gives you this number b. So we're going to apply this rule to help us to solve. If you look at this, you observe that these two bases are the same, just like this. These two are the same, and these two are the same. So apply this rule here. We have, for this, we have 2 plus, for this, we have 2 squared, for this, we have 2 cubed. And that gives us 2 plus, this gives you 4, and this gives you 8. So if you add this, it gives you back 14, and that is what we have at the right side. So it means that x we got as log of 2 base 3 is absolutely correct. And I hope you really learned something today. If you did, don't forget to tell us how much. Give this tutorial a like. Sharing it to help the algorithm to send to more people. Thank you for choosing to learn through us. I'll see you in our next class. Bye-bye.